Alright, grade 12s, welcome back to the second part of the video tutorial. When we finished the first part of the tutorial, I finished up a bunch of limit questions. And to start off the second video of the tutorial here, we're going to look at some continuity questions now. So, for your test, you should expect to see at least two continuity questions. The first question is going to be very similar to the question that you see right now. If I have a function f of x, I need to show that it's continuous at some point, and my point right here is going to be x equals to 2. So for this kind of a question, I need to show that it's continuous at x equals to 2. Now for these kind of questions, continuity involves there's a three-part definition for continuity. So we did this in the, during the in-class assignment. So there are three conditions. The first condition was, first of all, f of x, or sorry, f of a has to exist. That's condition number one. And for condition number two, the limit as x approaches a from the left-hand side and the right-hand side, so the limit must exist. And if the limit exists and if f of a exists, then the final condition was f of a must equal to the value of your limit. Alright, so in order to do this question, you must satisfy all three of these conditions here. Okay, so let's get started here. So my point is x equals to 2. I want to see if, does this point exist? Alright, so that's the question. So the question is, do I have a y value for at x equals to 2? So I need to evaluate f of 2. Now f of 2, that's simply going to be this middle guy right here, because this is the only point on the graph where x actually equals to 2, so f of 2 equals to 9. So since f of 2 equals to 9, since we actually have a y value, that satisfies condition number 1, f of a does exist. In this case, a was just a value of 2 here, so f of 2 does exist. Now for the second criteria, I need to evaluate the limit. I need to evaluate the limit from the left-hand side and the right-hand side. Now, for this kind of question, 2 is my point of interest right there, so I will have a right-hand side and I'll also have a left-hand side. Now, if you go back to your original equation here, f of x equals to, sorry, your piecewise function here, you have to recognize that. Let me just delete this part now. Sorry, let me just delete this right here. You need to recognize that this expression right here, x is less than 2. That's going to be this part of the number graph, x is less than 2. That's the left-hand side. So this is your left-hand side. And when you have x is greater than 2, which is over here, x is greater than 2, this is going to represent your right-hand side. Okay, so hopefully you can just look at your piecewise function there, and you can. What you want to do is you want to be able to look at this and quickly identify your left-hand side and your right-hand side. All right, so let's evaluate the limit now. So if I evaluate the limit as x approaches 2 from the right-hand side, this is going to be 3x plus 3. And if I evaluate my limit from the left-hand side, x approaches 2 from the left, this is going to be the function x plus 7. Alright, so from here on, what you want to do is you just want to use direct substitution. So the quickest way to do a problem like this is just take your 2's, and just substitute them in for your x value. So this will be 3 times 2 plus 3, and that's going to give you a value of 9. And if I take this 2 and if I substitute that in for the x over there, I get 2 plus 7, and that will also give me 9. So notice here that my right-hand limit and my left-hand limit, they're equal, so that satisfies the second condition that the limit does exist. Now, before I move on, I just want to talk about this limit question one more time. If you go to your number line, and if you're looking for a number on the right-hand side of the number line, you might think that you can use the number 2.000 repeating 1. And some students may want to. Some students get into the habit of doing this number line. Some students get into a habit of using the number line technique for every single question, and you have to realize that sometimes you don't have to do the number line technique for every single question. For example, if I use the number line technique and if I use this number and if I try to substitute that directly into here, you need to recognize that 2 is pretty much the same thing as 2.00000 repeating 1, alright? So you don't have to insert this this decimal answer here, 2.0000 repeating 1, because that's pretty much the same thing as 2, okay? So keep that in mind when you're using these number line techniques. Sometimes you really don't have to insert the entire decimal answer into your question. Okay. Alright, so now that I've gotten that out of the way, erase this, erase that, erase all of this. You'll notice that my limit does equal to 9, and what about my third condition here? Is this third condition true? Well, f of a, that's going to be 9, that's over here. And my limit also equals to 9 because I evaluated that over here. So since f of a equals the limit of f of x as x approaches a, I can definitely say that my graph is continuous at x equals to 2. And let me just kind of erase all of this now, and I will move on to the second question in just a bit here, but I just want to kind of give you guys a visual diagram of what this piecewise function looks like. If you did have time and if you did want to graph all the individual parts, your graph would look something like this. Here's 2 and something like that. So if you did take the time and graph all 3 of these parts of the graph, if you graph them, you would get something like this, and clearly you can see that we are continuous at x equals to 2. There's no holes, there's no asymptotes, there's no gaps. It's definitely continuous at x equals to 2. Alright, let's move on to the next question. For the next question, it's another continuity question. For what values of k is the function f of x? So f of x is another piecewise function here, and I want to know what value of k would make this thing continuous at x equals to minus 3. Okay, so once again, you're guaranteed to get a very similar question like this on your real test. Okay, so let's take a look here. How can we approach this question here? Well, if we if we follow the three-step definition of continuity, we need to show that f of -3, this has to exist. Okay, so where on your piecewise function are we valid for x equals to 3? Well, for x equals to 3, if I move this over here, it's definitely going to be that middle part right there. So what we're going to do over there is we're going to just set f of -3, and we're going to make that equal to that middle part there, which is k squared minus 5x, or 5k. Alright, so let's just make f of 3 equal to k squared minus 5k. Alright, so that was condition number 1. Condition number 2 of the continuity definition was when the limit as x approaches -3, does it exist? Okay, so for this kind of question, for this part right here, we need to set up our limit statements here for the left-hand side and the right-hand side. So going back to my piecewise function here, I can see that this part right here is going to be my left-hand side, and this one over here is going to be my right-hand side. Okay, so let's set up a limit statement for the left-hand side and the right-hand side now. So if I have the limit as x approaches 3 from the right-hand side, that's going to be 6. And if I have the limit as x approaches 3 from the left, that's going to be -6x minus 12. Okay, so now if I evaluate these limits here, this limit right here, well, that's simply going to be, that's just a constant, so that's just going to be give me a final answer of 6. And for this limit statement right here, if I evaluate that using direct substitution, what that means is I take this 3 and I substitute that for every single x. If I do that, I get -6 times 3. Oh, sorry, this is supposed to be a -3. So -3 minus 12. That's going to give me positive 18 minus 12, and that's going to give me a final value of 6. So that's good news. That means my my right-hand limit and my left-hand limit, they're equal to 6. so my limit does exist. And for the third part of my continuity definition, I have to show that f of negative 3 must equal to the limit as x approaches negative 3. Okay, so in order to satisfy this third part right here, I know that my limit here, highlighted here in yellow, I know that's going to equal to a value of 6. So I'm just going to delete this now, and I will put a 6 here. And then you ask yourself, f of negative 3, what does that equal to? Well, that's just this expression right here in green. F of negative 3 equals to k squared minus 5k. So what I'm going to do here is I'm just going to delete this part here, and I'll put this expression in here now, k squared minus 5k. Okay, so just moving this over now. In order to solve this question now, I need to solve this polynomial here. This is going to be a quadratic here, so k squared minus 5k equals to 6. I need to solve this here, so this will be k squared minus 5k minus 6 equals to 0, and we can simply factor this now. Basically, for this I'll get k minus 6 and k plus 1, I believe, and our final answers here should be 6 and negative 1. Alright, so now that we factored that and we set our quadratic equal to 0, this should be my final answer, k equals to 6 and minus 1. Alright, let's move on to the next question. Now, I want you to put a star on this question here because this next question, it's very important. This question does take a little bit of time, and you know, I'm like 99% sure you will definitely get this on your chapter test. So the question is, if I have f of x equals to 2x minus 1 divided by the absolute value of x plus 1, if I have that, the question is find the vertical and horizontal asymptotes, and I need to justify my answer using limits. Okay, so this kind of question will take a little bit of work. So let's get started here. If I need to find a vertical asymptote, you have to know your definition of a vertical asymptote using limits. So a vertical asymptote basically means if you have a limit, and if you're approaching a certain value from the right hand side, or if you're approaching a certain value from the left hand side of your graph, basically if your final result has to be you need to approach positive or negative infinity. Okay, so basically if you evaluate your limit from the left or the right hand side, and if you get positive or negative infinity, that means you have a vertical asymptote. Now, the left hand limit and the right hand limit, they don't necessarily have to be equal. They just need to be, you just need to show that you're approaching, you just need to show that you're approaching positive or negative infinity, and that will show that you do have a vertical asymptote at that point. Okay, so let's take a look here. If I have, I'm just going to rewrite my graph right here. This is f of x equals to 2x minus 1 over the absolute value of x plus 1. Now, if you take a look at your denominator here, this x plus 1, I think most of you can agree that if the denominator equals to 0, then you will have a vertical asymptote. So if you take your denominator here, x plus 1, and if you set that equal to 0, you will get a value of x equals to negative 1. So it appears that you have a vertical asymptote at x equals to minus 1 just by looking at the question. You can eyeball the vertical asymptote. Now you need to justify your answer using limits. Okay, so using limits, you need to show that this expression here, if I approach negative 1 from the left hand side and the right hand side, I need to be approaching positive or negative infinity. Okay, so what I'm going to do here is I'm going to draw a number line here, and my point of interest will be negative 1. So I have a left hand side, and I also have a right hand side. Okay, so once again, we want to pick numbers to the left and to the right of minus 1. So this could be negative 0.999 repeating, and to the left hand side I'll use negative 1.000 repeating 1. Okay, so I have my number line set up, and then I'm going to write my limit statements. So I have the limit is x approaches -1 from the right of 2x minus 1 divided by the absolute value of x minus 1. And I also have the limit as x approaches -1 from the left of 2x minus 1 divided by the absolute value of x minus 1. Okay, so let's take a look at this. Okay, so if I'm evaluating this limit right here, basically what I want to do is I want to find my values to the right hand side of -1. So this number right here, -0.999 repeating, and I want to simply insert that into back into my equation there, or my limit expression. So I want to put this back into here and into there. Okay, now if I do that, I will get something like, okay, I'm running out of space here, so I'm just going to rewrite this down here. So if I do insert those numbers here, I will get, let me just rewrite this. I would get 2 times -0.999 repeating minus 1 divided by the absolute value of -0.999 repeating minus 1, close bracket. Okay, let me just put the absolute values in black there. Okay, so when you evaluate this expression right here, I can tell that if I look at my numerator here, 2 times -0.999 repeating, that's going to give me a negative value. And if I have a negative value and if I subtract another negative value from that, I will definitely get a negative answer on my numerator. Now for my denominator, this whole expression right here is inside the absolute value, so I will always get a positive answer on my denominator. So a negative divided by a positive will give me negative infinity. Okay. All right, now let's compute the left-hand side, the left-hand limit. And for my left-hand limit, I need to look at numbers to the left-hand side of -1. So I want to look at this 1.0000 repeating. Sorry, there's a minus sign there. Okay, so I want to substitute this number into my left-hand limit right here. So if I do that, I'll do that on the left-hand side here, or sorry, on the bottom here. So this is the limit as x approaches -1 from the left-hand side, and this is going to be 2 times -1.000 repeating 1 minus 1 divided by the absolute value of -1.000 repeating 1 minus 1, and this is all inside the absolute value. Okay, so let's evaluate this. So clearly the numerator here, if I look at the first part, that's going to be negative, and if I have a negative number and if I subtract another negative, I will clearly get a negative number on the numerator. And once again, for the denominator, anything inside the absolute value sign, you will always get a positive number as an output. So negative over positive will be negative. So I do get negative infinity as I approach -1 from the left-hand side. Okay, so basically from this, I can see that I do have a negative infinity from the right-hand side and a negative infinity from the left-hand side. So basically I would just finish off by saying that I do have a vertical asymptote at x equals to -1, since my limit as x approaches -1 gives me negative infinity. Alright, so there's my final statement right there. I do have a vertical asymptote at x equals to -1, because when I approach the limit from the left-hand side and the right-hand side, I do get negative infinity. Alright, so that takes care of the first part. Now the second part of the question is I need to find the horizontal asymptotes. Alright, so the horizontal asymptotes, I do need to I need to approach this problem again using limits. So let me just do this problem here on the side. Okay, so I'm just going to rewrite my equation again. My equation was f of x equals to 2x minus 1 divided by the absolute value of x minus 1. Now, before I get into horizontal asymptotes, I just want to talk to you guys about this absolute value function right here, because in order to do the horizontal asymptotes, you really need to understand how absolute value function works. So if I graphed this absolute value function here, absolute value of x minus 1, that's going to look like something like this. Get that V shape. And this is going to be... wait, sorry. Let me just go back to my original question here. It's plus 1. So sorry, this is supposed to be plus 1. So this will be negative 1. So sorry about that. I just didn't write the question down properly. So it should have been 2x minus 1 divided by the absolute value of x plus 1. Now, in order for me to do these horizontal asymptotes, you need to look at this absolute value function here. So the absolute value of x plus 1 here. And absolute values have two parts. They have a positive side and they have a negative side. Okay, so if you actually did like a number line with a negative 1 here, you have a right hand side and you have a left hand side. Now the right hand side is going to be represented by the graph of, well, this part right here in yellow, that represents x plus 1. Now what about the part in purple? What's the equation of the graph of the line that's highlighted in purple there? Well, that's going to be negative onto x plus 1, which is going to be negative x minus 1. Okay, so when we're dealing with the right hand side, I'm working with the equation x plus 1, and if I'm working with the left hand side, I'm working with the equation negative x minus 1. Okay, so you need to understand that before I do the horizontal limits here. Okay. So basically now I need to find a horizontal limit, and before I start the horizontal limit, you need to understand the definition of a horizontal limit. The definition of a horizontal limit means if you take the limit as x approaches positive or negative infinity of your function, you should get some kind of a constant, like a constant L. Alright, so if you take the limit of f of x, if you go to positive or negative infinity, you should get some kind of a constant value. And if you do get a constant value, that means you have a horizontal limit. Okay, so let me just delete this. And let's just start the problem just underneath here. Okay, so let's take the limit of this expression right here. Now, if I take the limit as x goes to positive infinity, you have to recognize that positive infinity is actually on the right hand side. Okay, so positive infinity is way over here on the right hand side. So if I'm on the right hand side, I'm dealing with the equation 2x minus 1 divided by x plus 1. Okay. And how would you evaluate this limit? Well, whenever you're taking a limit as x goes to infinity, you're always looking for the highest power of x in the denominator. And the highest power of x in the denominator here is just going to be regular x. So this will be the highest power of x in the denominator is simply going to be x. So if you had to simplify this problem now, this would be limit of x as x goes to positive infinity, and you would take every single term in your expression and divide by x. So divided by x, divided by x, divided by x, divided by x. And if you simplify this, you will get the limit as x goes to positive infinity of 2 minus 1 over x over 1 plus 1 over x. And now when you do a direct substitution here, you'll notice that these guys go to 0, and your final answer here is 2. Which is good. So basically what you're saying here is as the limit as x goes to positive infinity of f of x, you just concluded that it does reach a constant of 2. So that's good. We're halfway there into showing that we do have a horizontal limit of 2. Alright, so the next part that we have to do is now that I've done x goes to positive infinity, I need to show what happens when you take the limit as x goes to negative infinity. Now, when I'm going to negative infinity, if I go back to my number line here, negative infinity is way over here. Alright, so negative infinity is way to the left-hand side. Now, if I'm dealing with the left-hand side, I'm dealing with this equation right here, negative x minus 1. Alright, so if I go back and write my limit statement here, this is going to be 2x minus 1 divided by, I'll put this in red here, negative x minus 1. Alright, so my equation does change a little bit because I'm working with the left-hand side now. But once again, this is pretty much the same problem as the one that we just did above. The highest power of x in the denominator is x. So if I take every single expression here and divide by x, I will get something very similar to the previous problem. The limit as x goes to negative infinity there, and if I do evaluate this, that goes to 0, that goes to 0. That just cancels out, and that cancels out to minus 1, so I get, so basically I have a 2 here, and I have a minus 1 there, so if I do this limit here, I get negative 2. And that's pretty good too. So what that means is if I have my limit as x goes to negative infinity of f of x, I have a value of negative 2. Okay. So these are my two concluding statements right here. If I do take the limit as x goes to positive or negative infinity, I do get a constant value here of 2 and negative 2. Now the limits, they don't have to be equal to each other, okay? We just need to show that we do reach a constant value when we go to positive or negative infinity, and that's true. We do have a constant value of 2 here. So if I did graph this, it seems like you do have a, let me go back here, you have a vertical asymptote at negative 1, and you have a horizontal asymptote at 2 and negative 2. So if I did graph this kind of a function here, you would have a vertical asymptote at, sorry, it was at negative 1. Okay, so if this is negative 1, maybe you do have a vertical asymptote kind of going like something like that, and maybe something like that. So maybe your graph kind of looks like this, where this is a value of 2 here, this is a value of negative 2, and you have a vertical asymptote at minus 1. So your graph could look something like that. Alright, so let's move on to some other questions. We're almost done this video tutorial here, thank God. One more question that you will have on your test is an average rate question. And for average rates, that's pretty much the same thing as finding the slope of the secant line. And if you want to find the slope of the secant line, that's the same thing as average rate equals to f of b minus f of a over b minus a. Okay, and I want to find the average rate for this function on the interval 2, 6. So 2 is going to be my a value, and 6 will be my b value. So I want to evaluate f of b, and I also want to evaluate f of a. So f of b in this case is the same thing as f of 6. So if I evaluate f of 6, that means I need to plug in a 6 for all my x's here. So this is going to be 3 times 6 squared minus 2 times 6 plus 1. So f of 6 is going to equal to 97. And for f of a, that's going to be f of 2, and that's going to be 3 times 2 squared minus 2 times 2 plus 1, and that's going to give me a value of 9. Alright, so if I want to calculate my average value here of AR here, that's going to be f of b. Well, f of b is 97, f of a is 9, the value of b is 6, the value of a is 2, and I just compute those numbers here. This is going to be 88 divided by 4, and that's going to give me a final value of 22. So my average rate for this question is 22 units. Okay, before I end this tutorial here, I do want to go over a few more questions regarding, sorry, it was a question from the last in-class assignment when we're dealing with the limit of e. So I believe in one of your in-class assignments we did a problem where as the limit of x, when x goes to infinity here, you were given this identity here, 1 plus 1 over x to the power of x, and that was going to be equal to e. So before I finish this video tutorial, I do want to go over some last minute questions of limit questions involving e. Now, the key to this problem is you need to look at this second term in your bracket here, this 1 over x, and you have to ask yourself, what's the relationship between that 1 over x and this x on the outside here? And this x on the outside is the same thing as x divided by 1. Okay, so if I rewrite this 1 over x here on the bottom and highlight that in yellow, what's the relationship between this second term and your exponent? Well, you'll notice that the relationship is that they are reciprocals. Okay, so as long as you have a reciprocal situation on your second term and your exponent, the answer will always be e. Okay, so let's take a look here. If you have something like this, the limit as x approaches infinity of 1 plus 2 over x to the power of x over 2, and if I ask you what does this limit equal to, well, first of all, just highlight your second term there, which is 2 over x. I'll rewrite that below here, and then highlight your exponent, which is x over 2. Now, are these reciprocals here? And the answer is yes, they are reciprocal. So as long as you have a reciprocal with your second term and your exponent, the answer will always be e. The answer will always be e. Okay, just one more example here. If I did the limit as x goes to infinity of 1 plus, let's just say maybe 5 over x to the power of x over 5, notice once again that this expression right here and there, they're reciprocals. So if they're reciprocals, the final answer will simply be just e. Okay, I'm going to finish up this video by going over three different examples involving this limit here. So here's example number 1. The limit as x goes to infinity. Now you could go to positive infinity or you can go to negative infinity. It doesn't matter, you'll still get the same answer here, but I'll just stick with infinity here. So if I have 1 plus 3 over 2x to the power of let's see, what can I do here, to the power of x. Okay, so this is my question. The limit of x goes to infinity of 1 plus 3 divided by 2x all to the power of x, and the question is, what does this equal to? Alright, so when you approach this kind of a problem, I would just highlight your second term. My second term is 3 divided by 2x. Now ask yourself, what is the reciprocal of 3 divided by 2x? Well, the reciprocal of 3 divided by 2x is going to be 2x divided by 3. Okay, so my goal is I want to take this outside exponent here and I want to make that equal to this, 2x divided by 3. Okay, that's the goal here. Okay, so in order for this to work, I need to have a 2 here. I must have a 2, so that 2 matches up with this 2. Okay, now if I multiply this expression by 2, I need to divide by 2. So I'll put a 2 just underneath there. Okay, so this 2 right here and that 2, they'll just cancel each other out, so that won't affect my final answer, okay? Good. Now, another thing is I need to have this 3 here, alright? I need to have a 3 there, so I'll divide this whole thing by 3, and if I divide by 3, that means I need to multiply by 3. Alright, that way I won't change the answer here. Now, if you look at this expression very, very carefully, I'm going to put a bracket right here and a bracket right there. Okay? I'm going to erase this part right here. Now, ask yourself, I'm going to highlight this part in yellow right now. The things that are highlighted in yellow, are those reciprocals? And the answer is yes. So since they're reciprocals, this whole expression right here is going to equal to e. All right, and then what's left on the outside? Well, I have this 3 over 2. This 3 over 2 here highlighted in blue, that's just an exponent, so my final answer is e to the power of 3 divided by 2. That's my final answer. Okay, let's move on to another question. Now I have the limit as x goes to infinity of 1 minus 2 divided by x to the power of negative x. Okay, now once again for this problem we need to use this identity here. The limit as x goes to infinity of 1 plus 1 over x to the power of x equals to e. I'm going to try to use this identity here with the idea that this 1 over x and this x, they are reciprocals. Okay, so for this question, let's highlight the second term here. The second term here is negative 2 over x. Now, if my second term is negative 2 over x, what is the reciprocal of negative 2 over x? Well, the reciprocal of that is going to be x over 2 with a minus sign. So the goal is I want to make this outside exponent, I want to change that to this, to the reciprocal. That's the idea. Okay. Alright, so I have a 2 there, so what that means is I need to take this exponent and divide by a 2. Now if I divide by 2, that means I need to multiply the expression by 2, alright? So if I multiply the expression by 2, I haven't changed the original question. Now, since this part here highlighted in yellow, since these guys are right here, they are now reciprocals of each other, then I can use my I can use my identity right here. I can use this identity right there. So let me just put a bracket here and a bracket there. Let me just delete this. This whole thing in the bracket right there, that's going to be equal to e. And this outside right part, this outside exponent, you just add that on over here. So the answer there is just e to the power of 2. Good. Alright, one final question and then we're done the video tutorials here. I'm really sorry, I'm just like super tired, putting these videos together. If I'm stuttering, I apologize. These videos aren't easy to do. Anyways, one last problem and we're done. So I have the limit of x goes to infinity of 1 minus x over 2, all to the power of 1 over x, and the question is, what does this equal to? Okay, so let's highlight my second term here. So my second term is negative x over 2. And ask yourself, what is the reciprocal of this guy? And the reciprocal of that should be 2 over x. And so the idea is I want to get this outside exponent to look like the reciprocal. Okay, that's the idea. Alright, so for my reciprocal, I have a 2 on the numerator there, so I definitely need to have a 2 here. So if I put a 2 there, that means I need to divide by 2. And you'll notice that, sorry, I forgot this minus sign there, so there has to be a minus sign here. So there's a minus sign right there, and if I put a minus sign there, I also have to put a minus sign over here. Okay, so let me just put a bracket around this and a bracket around this, and you'll notice that are these expressions here highlighted in yellow, are those reciprocals of each other? So are these reciprocals now? And the answer is yes. So let me just delete this. So this whole bracket is going to be just e. And then what do I have on my outside here? I have, well, this is just going to be 1, so the answer here is negative 1/2. So e to the power of negative 1/2. That's my final answer. Okay, so that was the final problem that I'm going to do for this video tutorial. Your real tests will be very similar to the questions that have come up on this video tutorial. I'm just going to only have one question where you're working with this limit as, these final questions here, this identity question here with the e, I'm just going to only have one question on that. So if you did understand the questions in this tutorial on that, you should be okay. So one question on that. And I'm also probably going to have everything that you've seen through these video tutorials. All the other questions on the real test will be very similar. There might be one question where there might be one more difficult question that you haven't seen yet. I want to make sure that the test is going to be a little bit challenging for some of the top level students, so I want to make sure guys like Connor, they're not getting 100%, so there's going to be one extra hard question, but everything else should be very similar to the questions on the video tutorials. Alright, so if there's any questions, just email me or just ask me in class, so we'll see you guys for the test.